Students, let's start with trigonometry prove that sums. So whenever you start with trigonometry prove that sums, you need to remember three identities which you are going to use in this chapter. So first one is sin square theta plus cos square theta is 1. So whenever you are starting with this exercise, if you are a new learner, so always have the habit of writing these three identities in the side so that you can know how to apply them. So first one is sin square plus cos square is 1. Second one is sec square theta minus tan square theta is 1. And third one, cosec square theta minus cot square theta is also 1. So always use this identities. Have the habit of writing it in the side so that you can apply them easily. So here the question was 9 sec square theta minus tan square theta. As 9 is common in them, so we can take 9 common. We left out with sec square minus tan square. As per identity, sec square minus tan square is 1. So we'll replace that by 1. So thus the answer is 9. So this is asked in MCQs. Now let's start out with the exercise. Prove that questions. So here sec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. Whenever you are getting question in this way, always remember like either we can solve from the LHS or RHS. For this question, solving from RHS will be easy. So I'm starting this with RHS. RHS is given 1 minus cos theta upon 1 plus cos theta. If the same terms are there in fraction, we are going to start out with rationalization. So here plus sign is there in the denominator, 1 plus cos theta. We are going to multiply the whole equation with 1 minus cos theta. So multiply both the terms with 1 minus cos theta. As here it is 1 minus cos theta and 1 minus cos theta. So it will be 1 minus cos theta whole square. This is a plus b and a minus b identity. So we'll make it a square minus b square. Now here 1 minus cos theta whole square and in denominator 1 minus cos square theta. 1 minus cos square theta is sin square theta as per this identity. If we shift cos square towards right, that will be 1 minus cos square theta. So we can replace 1 minus cos square theta with sin square theta. So 1 minus cos theta whole square upon sin square theta. So whenever we are applying identity, you need to write it aside. Sin square theta plus cos square theta is 1. So from there you applied the sin square. Now as both the terms in sin square form, so we can shift them, we can combine them. So combining 1 minus sin theta, this is also one of the important trick which you need to remember. If suppose there is only single unit in the denominator, we combine them. So it is 1 minus sin cos theta upon sin theta whole square. Now 1 upon sin is cosec and cos upon sin is cot. So as this is in whole square term, so we got our RHS. LHS, we need to prove that cosec square theta minus cot square theta is 1 minus cos theta upon 1 plus cos theta. So this we got our LHS. Therefore LHS is equal to RHS. So this way simply we can solve it by using the simple identities. Now the next question, cos A upon 1 plus sin A, 1 plus sin A upon cos A. So we are going to take cos A 1 plus sin A as LCM. So here we'll have the cross multiplication, or you can think like these two are in LCM. So we are going to multiply cos. So cos multiplied by cos is cos square A. And the same way cos is there. So we are going to multiply 1 plus sin. So it's 1 plus sin A whole square. I write down their identities. Cos square A, here whole square is there. So it's A square plus 2AB plus B square whole divided by cos A 1 plus sin A. Now expand it. Cos square A 1 plus 2 sin A sin square A whole divided by cos A 1 plus sin A. Now cos square plus sin square is 1. So we can replace that by 1. 1 plus 1, 2 sin A upon cos A 1 plus sin A. Now here 1 plus 1 is 2, 2 and 2 is there, so we can take 2 common. So as I am taking 2 common, here I left out with 1 plus sin A upon cos A, 1 plus sin A. Now these again are like terms, so they get cancelled. So final answer is 2 upon cos A. If cos A is in denominator, it's 1 upon cos is sec. So we can replace this as 2 sec A, which is our LHS, which is our RHS. Therefore, LHS is equal to RHS. So in this way, if you are clear with your identities, as I am telling again and again, you need to remember all the 3 identities properly. And the first exercise, what are the reciprocal formulas? Like if sine is there, we can write it 1 upon cosec. Or cosec is there, we can write 1 upon sine. And the same way, if there is sec, we can write 1 upon cos, or for 1 upon cos, we can make sec. In the same way, if tan theta is there, we can change it with sine upon cos, as sine theta by cos theta is tan theta. Or we can write tan theta as 1 upon cot theta. So these are the formulas which you need to keep aside while solving this exercise, so that easily you can solve it. We are going to frequently use this formula and that 3 identities. So let's start out with the next question. This is one of the important questions for your board exams. So tan theta is there and then cot, both are reciprocal to each other. We are going to change each term in the form of tan. So cot I am replacing as 1 upon tan theta. Again here cot is there, so that I replaced as 1 upon tan theta. Now rest of the term written as it is. Now we can get LCM. So here taking the LCM tan theta. So 10 multiplied by 1, tan theta minus 1. Now 1 upon tan theta, 1 minus tan theta. Now we can see here 10 minus 1 is there, whereas here 1 minus 10. We can take minus common to make both the units equal, so that we can take LCM easily. Now shifting this 10 to the numerator, so thus it is tan square theta upon tan theta minus 1. Taking minus common from this unit, so this plus sign will change to minus tan theta minus 1. As I have taken minus common, so this got reversed. So this 1 minus tan theta will change as tan theta minus 1. Now getting LCM of the whole term, so it is tan theta minus 1. Tan theta is common, so 10 is getting multiplied. So it's a tan cube theta minus 1. Now a cube minus b cube is there, so we are going to use its identity, a minus b, a square plus ab. As it is 1, so I wrote only tan theta plus 1. A cube minus b cube identity, a minus b, a square plus ab plus b square. So this identity I applied here. Then denominator has to be written. Now tan theta minus 1 will get cancelled. So as I explained in the previous question, if there is only single denominator, we need to separate it below all. So I am going to make the separate division, tan square theta upon tan theta upon tan theta, and 1 upon tan theta. So this I separated just below every unit. Now 10 got cancelled. So here we are having tan theta, both the 10 got cancelled, and 1 upon 10 is cot theta. Now as I explained that formula which we can use from the first exercise of this chapter, tan theta is sin theta upon cos theta. So we can replace tan as sin upon cos plus 1. Cot can be replaced by cos theta upon sin theta. Now getting LCM. So here sin theta cos theta is LCM. So here we are having cos. So we'll multiply sin to numerator. So sin multiplied by sin is sin square theta. Here nothing is there. So whole the term will get multiplied, sin theta cos theta. And here sin is there. So it will be cos square theta. Now sin square cos square is 1. So write down the identity. Then sin theta cos theta as it is. For these two, we replaced it by 1. Now as again the single unit is there, so we are separating it. 1 upon sin theta cos theta and sin theta upon sin theta cos theta. So these are same terms, so they get cancelled. 1 upon sin is cosec, 1 upon cos is sec, and here nothing is left, so it's 1. So this only we are going to prove. So this only was required. So this was our RHS. So thus LHS is equal to RHS. So this is important question which need little practice. Practice it thoroughly 2 to 3 times. You'll be able to remember the solution, as it is very important for your board exams. Now in next question, 1 plus sec a upon sec a, we need to prove sin square upon 1 minus cos. So here for this type of question, we need to go for both LHS and RHS. So let's start out with LHS. As here the single unit is there, I already told we need to make the separate division. So I separated it 1 upon sec and then sec theta upon sec theta. That is both got separated. 1 upon sec is cos. So it's cos a. Sec a got cancelled. 1. So this we got as LHS. Let's start out with RHS. RHS sin square is there, which we can replace by 1 minus cos square theta. And then this, the denominator as it is, 1 minus cos a. If a will be there, write down a. If theta is there, use theta only. That is a minus b, a square minus b square. So we are going to apply identity a plus b and a minus b. So I wrote it as 1 plus cos a, 1 minus cos a, whole divided by 1 minus cos a. Now 1 minus cos a will get cancelled. So this will left out with 1 plus cos a, and even our LHS was the same. So LHS and RHS both are equal. Therefore LHS is equal to RHS. And let's start out with the next question, which is cos a minus sin a plus 1 upon cos a plus sin a minus 1, which we need to make equal to cosec a plus cot a. So here for this kind of questions, we need to always go for rationalization. So how we are going to rationalize? Always remember, we rationalize with denominator, where we change the sign of only negative term. Don't make any change in the positive sign, only negative to be changed. So here cos a minus sin a plus 1, cos a plus sin a. First we will write as it is the denominator, and now the rationalizing term. Don't change the plus sign. So I wrote this till here, cos a plus sin a. Here minus is there, so that we are going to make plus. Now cos a plus sin a, the term which we have taken, the same we will repeat in numerator also. As in maths, nothing can be added, nothing can be subtracted. So that means that both the terms got cancelled. Now we will adjust the sum in such a way so that it will make a plus b, a minus b identity. So here cos a plus 1 is making a term, whereas the minus sign is making the b term. And the same way here, cos a plus sin a is the a term and 1 is making the b term. So we are going to separate in that way. Cos a plus 1, as we are considering a, and then sin a as b. So I made it a square minus b square. And the same way, cos a plus sin a whole square and 1 separated as square. Now after completing this, just to expand it again, so it's cos square a plus 2 cos a plus 1. I made the identity whole square 1, a square 2ab b square minus sin square a, and again here also a square 2ab and b square minus 1. Now here 1 minus sin square will be cos square, so we can replace that as cos square and cos square sin square is 1, so that these two terms replacing by 1, 2 cos a is there and sin a, write them as it is. Now 1 will get cancelled. Now here 2 times cos a is there and 2 cos a. We can take 2 cos a common. So we'll have here, as 2 times cos square was there, we have taken 1 cos common. So 1 cos a, and here the whole term is taken, so it's 1. Divide by 2 cos a sin A. So this 2 cos A will get cancelled. Whenever there is single term, we need to make it separate. So here it is cos A upon sin A plus 1 upon sin A. Cos upon sin is cot and 1 upon sin is cosec. So thus we got our RHS. So therefore LHS and RHS both are equal. So here in the next question, under root 1 plus sin A upon 1 minus sin A. So I'm going to start out with LHS. So as I told you, whenever the terms are there in fraction, we need to go for rationalization. So here denominator is 1 minus sin A. We are going to take opposite of that. So it will be 1 plus sin A. Multiply it to both the terms, 1 plus sin A to numerator and denominator. So the numerator is 1 plus sin A whole square, whereas the denominator a minus b, a plus b. So we'll make it 1 square minus sin A square, that is a square minus b square. Now write down the identities. 1 plus 2 sin A sin square A upon 1 minus sin square A. 1 minus sin square A. 1 minus sin square A is cos square A. So here this term we can make it little simple by changing from here. Here it is under root 1 plus sin A whole square. Here 1 minus sin square A was there. So we can make it cos square A. 1 minus sin square is cos square. Now both the terms are in square. So we can make it single unit. So as we did for the previous question. So making it 1 upon cos plus sin A upon cos A whole square. So this whole I turned into square form. Now 1 upon cos is sec and sin upon cos is tan. The whole term is in square form. So square and root both will get removed. So thus the final answer is sec A plus tan A, which is our RHS. So if you go in this way, the question will be little lengthy. So in this way, if you convert the term into cos, the sum will become little smaller and easily you can complete it. So thus LHS and RHS both are equal. Now let's start out with the next question. This 8th question is very simple and this was asked in 4 years back board exam also. Though the question is very simple, but students often make mistake in this. Once you concentrate on the question so that you will remember it for the longer, at least till your exams. So let's start out with the solution, how you can remember it. Here sin plus cos, cosec whole square is there. So simply use the whole square identity. A square 2ab plus b square. In the same way, again using the identity, so it's cos square A, 2 cos A, sec A, sec square A. Now sin square plus cos square will make 1. So apply identity for that. Sin and cosec both are reciprocal to each other, so they get cancelled. So we left out with 2. And the same way, cos and sec are reciprocal, so that will also get cancelled. Now it is 2. For cosec A, we can write it 1 plus cot square A. And for sec, we can replace as 1 plus tan square A. Now add out all the numbers. So it's 5 plus 1, 6 plus 1, 7. 7 plus cot square A plus tan square A. This only we need to prove. So we got our RHS. Therefore, LHS and RHS both are equal. Practice each and every question 2 to 3 times. For your better preparation, you can go with R.D. Sharma also. R.D. Sharma, whatever the CBSE questions were there, like they were asked in previous year questions. So practice out all those. If you are feeling some difficulty to understand any solution, you can send me the question in your comment box so that I'll explain that in in my next video. Now here the next question. Sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. We can take sin common. So taking sin theta common, so this it is 1 minus 2 sin square theta upon, in the same way taking cos common, cos theta, so 2 cos square theta minus 1. Now sin upon cos is 10, so replace this with tan theta. Here 1 minus sin square is there 2 times, so we can write it 1 minus sin square theta minus sin square theta. And the same way in denominator 2 times cos square theta is there, so we can change it cos square theta plus cos square theta minus 1. Now tan theta 1 minus sin square theta is cos square theta, and repeat this next term as it is sin square theta. Now cos square theta 1 minus cos square theta minus 1 will be minus sin square theta. So have we got this? You know the identity, sin square theta plus cos square theta is 1. If suppose I'm shifting this 1 this side and sin that side, this will be cos square theta minus 1, where the sign will, as we are shifting that side, it will be minus sin square theta. So I replace 1 minus cos square minus 1 as minus sin square theta here. Now we got both numerator denominator same, so they will get cancelled. So thus it is tan theta. So which we got our RHS. Therefore again LHS and RHS both are equal. Let's start with next question. Here it is sec A minus sin A. Both are reciprocal terms. So again going to change this cosec as 1 upon sin A and keep the next term as it is. And the same way sec and cos is there. Sec is 1 upon cos minus cos A. Now get LCM for this. Sin A is LCM, so it's 1 minus sin square A, and here cos A is LCM, so it's 1 minus cos square A. Now 1 minus sin square A is cos square as per the identity, writing the sin A as it is, and 1 minus cos square is sin square, and cos square to be written as it is. Now we can cancel the like terms here, sin will get cancelled, so we're left out with cos A and sin A. So let's start out with the RHS. So this was our LHS. RHS, it's given 1 upon 10, which we can write sin upon cos and cot as cos upon sin. Now getting LCM, sin A cos A. So here sin will multiply, so it's sin square A, and the same way cos is getting multiplied, so it's cos square A. Now sin square cos square is 1. So here we can write it 1 upon sin A cos A. As sin A cos A is in division, so it will get reciprocal. So finally we left out with sin A cos A, which is our RHS. So now LHS and RHS both are equal. So we can make LHS equal to RHS. Okay, let's start with next question. This is the last question of this exercise. 1 plus tan square A is there. So identity of 1 plus tan square, we can replace it by sec square A. And the same way 1 plus cot square can be replaced by cosec square. So here total 2 terms are there. So this is the first term which we are making equal to tan square. Now sec square is reciprocal of cos. So we can replace sec square as 1 upon cos square and cosec square as 1 upon sin square. Both the terms are in division, so they get reciprocal. So finally it is sin square upon cos square. Sin upon cos is tan square A. So we got the term which is equal to tan square. Now let's start out with the second term, that is 1 minus tan A. Tan can be replaced by sin upon cos, and the same way here cot A is there, which can be replaced as cos upon sin. Whole term is in square form. Now get LCM for this. Cos A LCM, so 1 multiplied by cos is cos A minus sin A. In denominator we are having sin A as LCM, so it's sin A minus cos A. Here we can say that both the terms are same, but there is sign difference, so we can take minus 1 common. If we take minus 1 common, this will be sin A minus cos A, terms will get reversed upon cos A, and the same way sin A minus cos A upon sin A. The whole terms are in square form. 1 square will be minus 1 plus 1 only, so it doesn't matter whether we have taken common or not. Now the like terms will get cancelled. Sin A is getting cancelled. Now sin and cos both are in division, so they get reciprocal. So the term is sin A upon cos A square. Sin upon cos is 10, so we can make it 10 square A. Thus we got all the three terms as 10 square. Therefore first term is equal to second term is equal to third term. So thus we proved it. So better repeat it 2 to 3 times so that you can prepare it well. If you have any queries, you can send me the comment. In my next video, I'll prepare the solutions for that. Thanks for watching.